Hello. So today, let me just give you a demonstration of what we're going to do. So here is the vanilla Super Mario Brothers game. And you can see it says Mario and World and Time, but here is a hack that I made earlier today. And if we open it, it says Ethan at the top. So we're going to be learning how to edit the text in Super Mario Bros. And while we do that, we're also going to be learning about character encodings and how you could edit text on other binaries as well, and not just Super Mario Brothers, but expand it to all sorts of things. So yeah, so today, what I'm hoping is that you will go and edit the text in Super Mario Brothers, and then you will create a patch file, and I'll explain what that is, and then you will send your patch file in the Discord with a description of what you changed. So you'll need to make sure you have the NES hacking tools and a ROM. Seems like most of you already have that. And yeah, if you have questions on how to do that, you can go to the previous lecture. And if anyone is using macOS, I hope that you have access to Windows for today. All right, so let's start talking about character encodings. So I guess without even looking at this, can anyone give me a definition of what a character encoding is?
Is it like converting whether it's a letter or a number to a binary string?
Exactly. Yeah. So, but can we get a little bit more broad with that? So it's not just a binary string, but maybe something else. We're using binary because we are computer scientists or computer engineers. But there's all sorts of ways that we can make character encodings. But the main definition of a character encoding is you're going from some analog shape into some discrete value. So like, for example, like if you have like the letter A and the letter D, if I were to just describe it, it's like, okay, like it's a little circle with like a stem poking up. It's like, well, actually these kind of look like the same because they're both like a circle with a stem poking up. And it's like, okay, like P and Q, like, or what if someone like draws their Q kind of sideways and now all of a sudden it starts looking like some weird other shape. So these symbols are analog. If we look at them, we're not exactly sure like what symbol it could be. But just after years of being humans, we've gotten really good at deciphering what letters are. But computers are really, really bad at deciphering what analog things are. So we need to convert it into a discrete medium. So examples of discrete mediums might be, so I talked about Morse code and Braille, which are very clear. Like you can't argue about like what that value is. If you see a Braille dot structure, it is very obvious. Oh yeah, that is an O or that is an A. But if you see like, if someone were to write out like an A or an O, like I don't know, maybe some people's A's look like O's. So it's yeah. The whole point is we are converting from shapes into something that is not possible to be argued with. And in computer science, what we use is binary strings, like was brought up. Yeah, but the question now is, yeah, which numbers should go to which letters? Like which binary strings should go to which letters? And I have this picture right here that has, it's called a 16 segment display. And these were very popular on the first computers. Yeah, because computers didn't have, like in like the 1950s, 1960s, they didn't have these really fancy like OLED or LCD screens that we have today. Instead, they just had these like either like 7 segment displays or 14 segment or 16 segment displays. And somehow they needed to convert from text into these shapes, or like lighting up these LEDs according to what should be lit up. And so if we were to look at like the pin diagram of an individual 16 segment display, we can see like, oh, okay, so if we put 5 volts on this pin right here, then it'll light up this section. Or if we put 5 volts on this pen, then it'll light up this section. Or if we light up if we put 5 volts on this section, it'll light up on this section. And so we can go through and say like, oh, 5 volts, 5 volts, 0 volts, 5 volts, 5 volts, 0, 0, 0. We can abstract that and just make that a number and say, okay, so like 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, and we can just write it out as a number. And so that's actually what some of the very first computers would do, is they would assign the number to the character that would light up the 16 segment display in the correct way. So we can see like A, I wrote out what the encoding is for A. We can see, so it should be lit, 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 so lit, 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 and then off, 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 and then lit, lit, according to these numbers. And we can see like up here, wherever A is right here. So yeah, lit, 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 off, off, lit, lit. Yeah. Lit, 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 off, off, lit, lit. And then here around in a circle, so off, 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 on, off, 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 on. So off, 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 on, off, 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 on. So yeah, this is what computers would actually do every single time they would display a character. And this is how they would store text, is they would have just a bunch of these 16-bit binary strings that would represent which LEDs would light up on the 16-segment display. And fun fact, Intel, the x86 CPUs, like basically all Intel CPUs actually still support this encoding. So if you were to go and use, like pull your CPU out of your computer, I'm sure all of you have Intel architecture. If you were to pull out your Intel CPU and then go and slap it in a machine from like 60 years ago in like the 60s, it would still support this sort of encoding. However, it's not really used today. It's kind of there because the x86 architecture has a lot of backwards compatibility, because that's just what Intel likes to do. The next question is, why is this no longer used? Like, are there some? So this is kind of discontinued. No one really uses this anymore. Can anyone think of why this may not be used anymore? And can someone like put it in the chat or say it?
Is there a more concise way to do it?
Absolutely. Yeah, that's totally one of them. So yeah, Sammy's going the other way. He's saying that there's this is not concise enough. And those are two very good answers. So one thing looking at this that's immediately clear to me, it's really hard to run any sort of like alphabet sorting algorithms. That's kind of a big one. You can't really say like, oh, like A is less than B, because, or I guess in this case it is, but yeah, but like B, if you were to compare the binary strings, B is greater than C, which shouldn't be true if you were sorting alphabetically. Another thing is if you wanted to create like a random string of characters, it's hard to tell what even is a character. Because if you were to just light these up randomly, the chance of you actually landing on a shape that is a proper character is pretty low, because there's so many different values it could be, and here are all the different values that are supported. So it's better to have these not be like corresponding to the shape. So therefore, there was a push to get away from this style of encoding. And what came about was ASCII in 1963. And ASCII was the first successful attempt at ensuring all text use the same mapping from binary characters. And so kind of funny, yes, so all CPUs, when I was saying that CPUs still support this sort of encoding, what really they support is converting from ASCII into into this 16-segment display encoding. So ASCII has been around for a very long time and has absolutely been adopted as the standard basically forever. So if we were to like go and open up a file and like write some words in there, say like, oh, like IEEE rocks or something, then it will use this type of encoding. But so let me actually show you kind of what that looks like. So I'm gonna make a new file here, and let's just call it text. And yeah, so let's write out IEEE rocks and save this. Cool. Okay, we have this file, and we can like close it and open it. We'll always have this text. But what we want to do is we want to look at the binary data. So let's go and open it in Visual Studio Code and open it in the hex editor. And so here we can see all the hexadecimal values for each letter. So if we push it off to the side, and look, so yeah, so we can see so I, and if we look on this table for I, oh, here it is. So 49. So 49. Boom. Okay, so now 45 is an E. So we look for E. 45. 45. 45. Yeah. So all these are E's, and then 20 is a space. So let's look for 20. Yeah. So 20 space. Okay. Cool. 72. 72. So if we wanted, we don't even need to open up this this text file and like go and like type stuff out. If we wanted, we could add more. We could say like hello there and save this, and then now like more is added. If we wanted, we could just edit it right here, and we could use this table. So instead of saying like IEEE rocks, we could say like let's just make these all spaces, and boom. So I rock. Yeah, very good. And then we can save this. And now if we open it up, now it says I rock. And yeah, we could change it to whatever we wanted. We could change it to like 37, which I guess is the character for 7. And there we go. So if you wanted, it would be very, very inefficient, but you could like go and like write all your essays in a hex editor as long as you just had every single character their encoding memorized. And if you remembered how it was written in binary, you could just write out each of the binary values for each character. All right, any questions on that?
So did the developers of Super Mario Bros. Edit the entire hex file?
No, the developers used they used 6502 assembly and then compiled it into the hex.
I see.
Yeah. Yeah. And if you're not sure what those words are, I'm sorry. But basically, they wrote it in a way that was a little bit easier for them than just going in and editing it with hexadecimal. They had a little bit more help, but it was not much easier than writing it this way. This is actually how, back in the day, people actually had to write code. It was using very similar strategies to what I'm telling you right now is actually going into the hexadecimal and changing like, oh, okay, like here, like I need to change that to that. Yeah. All right. Yes. So next, let's, yeah, okay, so since 1963, there have actually been several more character encodings, such as Unicode and yeah, ISO 8891. But all of them are actually based off of ASCII. So if we look here, so we can see, we can see at the bottom here, it says UTF-8. So it's not actually encoding everything with ASCII, it's actually using UTF-8 to encode. In UTF-8, the reason why all of these numbers, all of these numbers from the table still work is because UTF-8 is actually based off of ASCII. So that's why the original ASCII values still work, because ASCII is very backwards compatible with everything. And so since ASCII is so widely used, it's used in absolutely everything, you can expect that Nintendo probably used ASCII when they were writing the text of their game. And so for games like Wrath of the Black Manta, you would be correct. So let me go and open that file. All right. Also, so quick note. So all of these, I have all these ROM files that are all .NES. Really good practice that I found is to just make all of these files read only, so that you don't accidentally edit them when you didn't want to. So so you would need to right click on it, go to properties. There you go. And yeah, so there's a little checkbox right here that says read only. So I always like to click it anytime I'm working with a ROM file. And if I ever want to edit it, then I just go and make a copy. And then instead of calling it vanilla, I might call it edited or something. And then I can properties, make it not read only. So now vanilla is read only, and I can not edit this. If I were to try to open it up in Notepad, so take a while. Oh yeah, okay. And like this, and then try to save it. It'll try to like save as, because it can't save. Versus edited, you can save. Cool. Okay, so let's open up the Wrath of the Black Manta in Visual Studio Code. See it in the hex editor, and looking at the hex editor, so we can see that the first 3 bytes actually spell out NES, and that is true for all NES files. That is called the header. It's very common. Look at the binary of some file, and usually the first few characters will explain what the file is. So this is an NES file. If we were to open up a wave file, it would spell out wave. If we were to open up the patch file that we're going to make later, this patch file that I mentioned earlier, that would spell out patch. So boom. So now that's one thing that we know what's going on in this ROM. And so, and if we scroll down, there's a lot of data here, but we can try to find some text in here. So let's go and search for text. Let's look for start, because it probably says like push start button. Yeah, look at this. Yeah, so it says push start button. But I don't want to push the start button. What if I want to like change this? So I can go to ASCII, the ASCII table. Now I can edit it. So instead of saying push, maybe I can say like, I don't know, like 54, and then 42. So now it says but start button. So I can save this, and so I'm going to open up the vanilla ROM file, and you can see it says push start button. And if I open up the edited one, now it says but start button. Woo! We've hacked it. Yeah, and that's as easy as it is for this game. Yeah, all you have to do is just kind of search for the text and edit away using this table. However, unfortunately, this does not always work, because not all games actually use ASCII. So not all game developers chose to make life easier for hackers by using ASCII. Most games developed by Nintendo actually use a custom character encoding. But fortunately, hackers have already reverse engineered the text encodings for us. So we can open up the Super Mario Brothers encoding. And so here's the actual table file for the game. And we can see like, oh, okay, so the letter A actually has like the value 0A. And so the letter like S has 1C. So let's go and edit the Super Mario Brothers file now. So so step 1, so we take vanilla and we can copy this, and properties, make it not read only, so we can edit it. Click OK, and rename it to edited. All right, now open with code. And okay. So now we have, and we can see that it's an NES game, and Super Mario Brothers 1. So this is all the code to Super Mario Brothers. So let's try searching for Mario and see if we can try to change Mario to something equally as funny. So let's search. So where's M? M is 16. and then 0A. So we're searching for the any instance in this game's code where it says the word Mario, except using this text encoding that was given to us by these hackers. So yeah, so 0A, and then now we're R, I, 12, and then O, 18. So Mario. So this, in theory, spells out Mario in the game's text encoding. And here is an instance of where it actually shows up. And we can see that there's actually a few times that it says this, which makes sense because it's a Mario game. So it should probably have have Mario like spelled out in it quite a bit. All right. Does the decoded text column have any use if the game is using custom encoding? That is a fantastic question. For Visual Studio Code, no, absolutely not. This is all completely useless information now. However, we're going to be using a tool called Goldfinger right here that lets you use your own custom text encoding. So all of the decoded text will show what the correct Super Mario Brothers text is. But for now, yeah, this is completely useless. But yeah, so we see Mario is spelled out in a bunch in it. So let's go and change the text now. So does anyone have an idea of what we should change it to? Anything funny? Wario. That's a good idea. Yeah. Okay. So question. So how are we going to change it to Wario? What do you think? How do we change it? This says Mario. So how are we going to change this to say Wario? 20 instead of 16. Yeah. Does that make sense, everyone? So 16 is the letter M. So we just need to change this 16 to 20. And now it'll say Wario. So let's test the hypothesis. So let's go and say, so anytime, this is find and replace. So let's say anytime we see the word Mario, let's change it to Wario. So so in theory, as soon as I click replace all, it'll replace all the text to Wario. And so edit it, and I just saved it. So let's look at the vanilla version really quick. Yeah, so it says Mario, and now if I open up the edited, now it says Wario. Yay! Yes, so I want to show you actually Goldfinger. So Goldfinger is really, really cool because we can open up text encodings. So so when you open up Goldfinger, you can click Open Table, or open Current Table. And I've made this little Super Mario Brothers text map for you. So go and open that. It should be in your Goldfinger folder. So if you open this, and then we can open up the edited ROM. And so now if we scroll down to about here, yeah. So yeah, right here we can see it says Wario because we changed it. And if we scroll down more, we can see time up, game over, welcome to Warp Zone. So this is how I highly recommend actually going and editing all the code. Is you go and you click on something, and then you go and edit it. So and then once you edit it, then you go and you save it. And then you have your fully completed hack. And once you've saved it, then you go and open it in an emulator and make sure that it all works. Are there any questions on the exercise for today? Basically, it's just you go in and edit the text however you see fit. And really quick, I'm going to show you lips. So Lunar IPS is what we're going to use to make the patch file. So a patch file is the preferred way of sharing ROM hacks with others. So if you ever go and Google like, oh, Super Mario Brothers ROM hack, what will come up is probably a Lunar IPS file. And because what Lunar IPS does is it doesn't store any actual ROM data that that Nintendo wrote. Instead, it only stores the data that you changed. And so that means that like there's nothing illegal that's happening. All you're doing is just saying like, hey, I changed the file in here, 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 and here. And then you can go and take that file and apply it to a ROM that you have. So I'm going to show you how to make a ROM really quick. So we want to do create IPS patch. First, it says, so select unmodified file to use. So we click the vanilla one. And then now it says select modified file to use. So we can open up the edited one. And then here, yeah, select IPS file to save. So yeah, so we can say SMB1 edited IPS. Save. Cool. And now we have this Wario patch file right here. SMB1 edited. Next, what you will do is you will go into Discord, and in the Discord, you will go and just drag it in and say, we edited the, edit all Marios to, yeah, so just when you're done, go and upload it to the Discord, and that is when you are done with done for the day, and that is when you can leave.
Also, I have another question. So, are we allowed to do like 3 letters or 7 letters, or is there a character limit?
So you're saying like, can you change Mario to be like 7 letters?
Yeah.
Not easily. I'm going to say no. So you must stay within the bounds of how many letters the game has said that you can use.
I see.
Yeah. However, like there are ways of changing the amount of characters that would be loaded to that location on the screen, but that's beyond the scope of this class.
All right.
Oh yeah, actually, let me talk a little bit more about hex editors. So up here we can see offset and size and character. So the offset is the main thing that you should be worrying about. The offset basically says like what memory address it is at in the file. So we can see like, oh, okay, so this is at 0, this is at 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. And then it goes to 1, 0, 1, 1, 1, 2, 1, 3. So the second number, or the second number corresponds to which row it's on. And the first number corresponds to, or the least significant number corresponds to which column it's on. And so if you wanted, let's say like you wanted to go to like a certain point in memory, you're like, oh, like I know that at like the offset like 765, that there is some text. And yeah, so we can actually see like, here's actually where it spells out Mario. So if you remember, it was like 16OA 1B12. This actually spells out Mario. Yeah, and then once you're done, you go and you save the file.
How did you make the LNK files, the shortcut files?
Oh, yeah. So I have this, I have tools, and what I like to do, so I just click, on like create shortcut, and now it creates a shortcut, and I'll do Control X to.
Oh yeah, okay.
And then I'll go and put it somewhere else. So I'll like go and put it in lectures, I can put it here, and then I usually rename it, get rid of all this.
Oh, okay.
Yeah. Or if you wanted, you can click on the like the link or the URL or whatever this is called, and drag, and that'll create a shortcut to wherever that is. Yeah. So. For anyone who's going a little bit slow, I'm gonna actually walk us through like start to finish once again, like how to actually go and create the patch file. So we have this ROM file. We can make a copy of it and make it not read only. Rename this to edited. And open it up in Goldfinger. So now we've opened up the file in Goldfinger. And now we can open up the current table right here at Super Mario Brothers text map. Open it, and now we see the text for the game. And if we go down to where the text begins, which is about 700, yeah, right here, we can go and change the text. And the way that we change the text is we have to go on the class website and open up this link right here, which is the Super Mario Brothers text encoding table. So now that we have this up, we can go and start editing the text. So we can find like all the instances where it says Mario. So I'm going to go into edit and search. And so let's search for Mario. So it's 16, 0A, R1B, 12, 18. I'm going to change it to say Ethan. So E, H, A, N, 17. Place. I think I can do Control F7. Yeah, so Control F7 will. Okay. So now I've changed all of the Marios to say Ethan. So let's also change this thank you to say you rock. So we can say so 22, 18, 1E, and space is 2A, R, 18, C, K. You rock. Are there commas? No commas. Sweet to be. You rock, Ethan. So now it says, you rock, Ethan, you rock, you rock, Luigi. Cool. And now I'm going to save this. I think it's a pretty good edit. And I can play this game now. There we go. Yeah, no. Oh, it says Ethan. That's okay.
Oof.
Happened. And really quick, I'm going to show you lips. So Lunar IPS is what we're going to use to make the patch file. So a patch file is the preferred way of sharing ROM hacks with others. So if you ever go and Google like, oh, Super Mario Brothers ROM hack, what will come up is probably a Lunar IPS file. And because what Lunar IPS does is it doesn't store any actual ROM data that Nintendo wrote. Instead, it only stores the data that you changed. And so that means that like there's nothing illegal that's happening. All you're doing is just saying like, hey, I changed the file in here, 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 and here. And then you can go and take that file and apply it to a ROM that you have. So I'm going to show you how to make a ROM really quick. So we want to do create IPS patch. First it says, so select unmodified file to use. So we click the vanilla one. And then now it says select modified file to use. So we can open up the edited one. And then here, yeah, select IPS file to save. So yeah, so we can say SMB1 edited IPS. Save. Cool. And now we have this Wario patch file. right here. SMB1 edited. Next, what you will do is you will go into Discord, and in the Discord, you will go and just drag it in and say, we edited the, edit all Marios to, yeah, so just when you're done, go and upload it to the Discord, and that is when you are done with done for the day, and that is when you can leave.